Chapter 6 is about divider circuits and the Kirchhoff's laws. This chapter has following sessions. 6.1 is about voltage divider circuit, and 6.2 is about Kirchhoff laws. 6.1 Voltage divider circuit. Voltage divider circuit or voltage divider method is just a method we can use to easily find the voltage drop on a resistor or multiple resistors in a series resistor circuit. In other words, if we know the source voltage and every resistor in this series resistor circuit, we can use this method to figure out the voltage drop of a particular resistor or multiple resistors. Of course, this method has more applications. Based on the voltage requirements for designing a circuit, we can use this method to figure out the required resistors needed to build that circuit. In this session, we have a few examples to show the applications of it. Before working on the examples, how about let's figure out the formula for a voltage divider circuit. First, let's draw a simplest voltage divider circuit. As shown here, this circuit is the simplest circuit. It has one voltage source and only two resistors. Resistors R1 and R2, they connected in series. This is the simplest voltage divider circuit. We can add more resistors, such as 3, 4, or many resistors in the circuit. So that circuit is a more complicated voltage divider circuit than this. Let's say we are interested in resistor R2. We want to know how much voltage drops on R2 if we know the source voltage. We also know resistors R1 and R2's values. Let's derive and get that general formula for this voltage divider circuit. We know R1 and R2 connected in series. The current penetrating this resistor is constant. We label this current and call it I. To find out the output voltage, which is the voltage across R2, we can simply use Ohm's law to figure that out. So V out or V2 equals to the current I times R2. Current I is the total voltage, which is Vs, the source voltage, divided by the total resistance of the circuit. That is R1 plus R2. So we replace I by Vs over R1 plus R2, and then multiply R2. Let's shift this expression to the right a little bit so we can get extra space in the front. The reason is, let's put Vs in the front and put R2 in the numerator. The only reason is we want to put the same quantities together. So Vs is voltage, and then the resistor R2 over R1 plus R2, that's the second group of quantity. They are all resistors. So here we get a equation for finding the voltage V2, that is Vs times R2 over R1 plus R2. Based on this expression, we can see the pattern already. To find the voltage across a resistor, what we need to know is the total voltage, the source voltage. And then put the resistors that we are interested in the numerator, in this case is R2. And for the denominator is the total resistance of the system. For this circuit, it's just R1 plus R2. If we have more resistors, we just need to add up all the resistors, that is the total resistance, put the value in the denominator. So this is the general formula for a voltage divider circuit.